In this session, we will learn how to perform multi-objective optimization while building a custom objective function. So here is the problem definition. There is a cylindrical can with a radius and a height defined. So we would like to minimize the cost of manufacturing of this can, but with a constraint of at least 33 centiliters of fluid should fill in this can. And we also have another objective where we have to maximize the transportation usage of the box of the dimensions 120 by 80 by 80. So these are the design variables, the height and the radius of this cylinder that can vary from 4 centimeters to 10 centimeters. So initially we will define the radius and the height value, and we will build the cylinder like this. Then we will define the objectives and constraint. So here the first objective is to minimize the manufacturing cost of this can. That means if we could minimize the total surface area of the cylinder, which leads to the minimization of the manufacturing cost. So that means we can take out the area of this cylinder and add the areas of all of the surfaces. In this case, we have like 3 surfaces, the top, bottom, and which is circumferenced, and that we get the total surface area. So we can make use of this component response and then define it as minimization of the objective. So this is the first objective function, and here we also have the constraint where we should design the can in such a way that it should hold at least 330 cubic centimeters of fluid in it. So in this case, this is the volume of the cylinder, which is pi r square h. We take the radius of the cylinder and square it and multiply it with the height of the cylinder followed by the value of pi, and in that case we can achieve the volume. So here we define the minimum constraint, which is 330, and next we will build another objective. In this case we have to maximize the transportation usage of a box which has the dimensions of 120 by 80 by 80. So that means we have to fit as many cylinders as possible in this box. So this is the objective function where it calculates the total number of cylinders that it can fit into this box. So we can simply calculate all of this, and then we have the transportation usage. So we have to maximize this transportation usage. So once we have defined this 2 objectives and the constraint, we can perform the optimization like we did in the previous session. So here we can see we have set up the parameter study and we have performed the optimization. So the optimization is already run and we have the results here. We can see that. So from the optimization, as we know, we can extract the best design like this by deconstructing the design, and we have the parameter values, these ones. So this is the most optimal design which satisfies our constraint that it would hold at least 330 cubic centimeters of fluid or 33 centiliters of fluid, while satisfying the objectives, that is minimizing the cost of manufacturing of the can, also maximizing the transportation usage in a box. So these are the values of the responses, that is objective functions and the constraints. So here we have seen how to build a custom objective function while also performing multi-objective optimization.